When we say artificial intelligence, what is it that comes to mind? We picture a situation where we have these humanoids, these androids, these robots who are, if not superior to us in intelligence, they are equal to us in intelligence. Now we've seen this in many movies. These robots, they have very human-like intellectual capabilities, and there are two what do we call it? Two groups of thinking. In one group, we have people say who advocate for developing artificial intelligence because we can train these robots, we can build these robots who will help us improve the quality of our life. To use economic terms, improve our utility. We can do less work, whether it's laborious work, working in the mines, or anything that is physically demanding, or even situations like this where you have to do very laborious technical work. And these robots can come here and do the work for us, or at least at the very least collaborate with us, and make our lives easier. And then the second group of people have this perception, right? If we make them too smart, then it will be a matter of time before they come and come knocking on our doors, and well, you get the picture. There is a one theoretical explanation why we cannot produce computers that can extrapolate, learn from extrapolation, and there was also a practical explanation for why it's not possible to create such sentient beings. First, let's talk about the three categories of artificial intelligence. Okay, we have the most primitive, which is narrow AI, and the most superior, which is of course super AI. Narrow AI is really what we call machine learning. And another name for machine learning, as you may know, is statistical learning. It's really just statistical techniques used on large volumes of data. Basically, it is a lot of the redundant tasks that a statistician would do, a lot of the basic arithmetic that a statistician would do, and it is automated with software. That's what machine learning is. Machine learning is, in very simple terms, statistics automated. Now, obviously, there's more to a statistic's job than calculating simple things like dispersion and variation. But a lot of it is automated. A lot of the things that statistician would do in order to perform analysis is very mundane. Machine learning is about automating most of that. Okay? And it will only, a machine learning model will be useful so long as there is no such, so long as there is no significant concept shift. Now that I've said concept shift, this is, in order to explain what that is, we have to go to a different realm. Basically, it is a significant shift in the distribution of data. And that is in the realm of ML ops, machine learning ops. By the way, if you want to know what machine learning ops is, I've recorded a workshop. You can watch that and you can see what that is. So it's about machine learning put in production. So in these three next workshops, we're going to look at machine learning on our computers. But we don't want it just to be on the computer, we want it to be on the cloud. But then once it's on the cloud, you need to monitor it. That's what MLOps is about. Anyway, I just want to, let's stick to here, and I'll tell you where you can learn more about machine learning. Anyway, so we have three layers. Narrow AI is using machine learning to do very, well, narrow tasks. For example, speech to text. For example, it's like a narrow, as a human being, you're capable of doing many things, correct? You're able to perform many tasks. Make a sandwich, make a telephone call, recognize somebody's face and greet them, and so on. So all of these are narrow tasks that we are capable of doing. And narrow AI is using machine learning to use one of these to perform one of these narrow tasks. Speech text is an example where you listen to audio and then you make a transcript of it. If you go to YouTube and you play a video, there is the closed caption option where you click the switch, and there is the text corresponding to the speaking person. It's not accurate all the time. There's a lot of mistakes in it, but that's an example of narrow AI. Another one is image classification, where you feed the model pictures, and the model will say, this is a car, this is a truck, this is a cat, etc. Now we are currently here. General AI is where we reach a stage where the system we have, whether it's using machine learning or a combination of machine learning and rules-based systems, rules-based is the construction programming, if and else statements, that kind of thing. So general AI is where we have a system that is equal to us in a intellectual capacity. So if you have a system that can learn like you, think like you, communicate like you, then we have reached general AI. Now, why are we quite far from getting to super AI? In order for us to get to super AI, that is a stage where machines are superior to us in intelligence, we must first be able to replicate our own intelligence. That makes sense, right? How can we exceed ourselves if we cannot replicate our mental capabilities? That is getting to general AI. So, and why are we not able to get to general AI? Because what is a human being? Like, what is it that makes us intelligent? It's our brain. Yes? Well, the thing is, we don't know much about the brain as much as we want to know. And this is in the realm of biology and psychology. We know a great deal about the brain, but not enough to replicate it. You've heard the story, where they examined Einstein's brain just to see what's going on. We still don't know we still don't know all the intricacies of the human brain. So how can we supersede? How can we ever produce such a super AI if we don't even know how our own brains work? And we're still here. So this is a practical explanation. There's also a theoretical explanation, but that's a discussion for a later time. Having said that, of all the machine learning techniques that we have available to us, deep learning is the most sophisticated. Why? Because deep learning is our attempt to replicate the human brain as closely as possible. So deep learning is how we can ever get to this point, if we can get to this point.